Hello, my friends. Thank you for joining me today as we begin a conversation on what is really one of my most favorite chapters in this course, this chapter on bonding and molecular structure. I really love this chapter because we're going to start to we're going to start to look at atoms and the connections between them, their bonds, and see how those bonds shape a particular molecule and how that shape gives that molecule certain physical and chemical properties. I admit I also like this chapter because it gives me a chance to show off some of my figures from my master's thesis, which is what you see in color here on the left-hand side. And it may just look like a bunch of colored curly Q ribbon, which it does kind of look like that. But what you see on the left-hand side is a figure of secondary structure of two proteins that I did my master's thesis on. And if you look closely at the structure, that secondary structure, you see that these two proteins, these two molecules are held together due to interaction between certain portions of that molecule. We'll talk about intermolecular forces later on in the course, but I mentioned this so I can show off my figures, but my master's thesis, the figures, but also to show that the structure of a particular portion of the molecule, particularly this blue residue called phenylalanine, those connections between the atoms in that part of the molecule gives that molecule shape and definition and interaction with this other green residue, this lysine in this molecule. And those interactions help give that molecule structure and its function. So in this chapter, we're going to talk about, on a smaller scale, how connections between atoms build and create a structure of a molecule and how that structure dictates function and properties. So before we go any further, let's review a little bit the two types of chemical bonding we have investigated so far. In ionic compounds, those species involve metals and nonmetals, and those species, those bonds, are due to differences in charges. The cation has completely donated an electron to the nonmetal, hence making it an anion. And so those ionic bonds are due to attractions between opposite charges. Whereas in covalent compounds, those molecules, those atoms are bonded together through the sharing of electrons, and covalent compounds are primarily nonmetals. Covalent compounds will be the type of molecule or the type of bonds that we will deal with most frequently in this chapter, but let's visit a little bit with ionic compounds in this Coulomb's law, because that will be covered in your MindTap, and there'll be a question about that on your online homework. When we talk about the force that attracts a cation and an anion together, the force between those two ions is directly proportional to the charge, the magnitude of the charge on the cation and the anion, divided by the square of the distance. So the higher the charge, the stronger the force. You don't need to know that equation, but you do need to know that fact about Coulomb's law. Now let's talk a little bit about covalent bonding and the fundamentals of it. So with covalent bonding, for that sharing of electrons to happen between two atoms, for that bond to be successful, that attraction between the electron of one atom and the nucleus, which is positively charged, of the other atom, that attraction needs to be greater than any kind of repulsion that may happen between electrons of those two atoms or between the nuclei of those two atoms. So there's a nice balance of when those atoms are at just the right position for a stable bond. That position, that distance, correlates to a particular energy. If you go on in chemistry, you will talk more about potential diagrams for particular molecules. You should just know that in covalent bonds, for that interaction to be successful, the attraction between the electron of one atom and the nucleus of the other needs to be greater than any repulsion that may be seen between electrons and nuclei, and that there is an optimum distance for that interaction to happen. So that is the end of this little vignette. In the next video, we will talk about how to use Lewis dot structures on an atom level and on a molecule level to say something about structure.